of came about by accident. Because I actually have a degree in zoology, and I'd always wanted to carry on with my studies, and an opportunity came up with a PhD for bio-inspired design. As many people know, climate change is a massive problem. Greenhouse gases are produced by transport, and one way of making reducing greenhouse gases is by making transport lighter, and so by making lighter weight parts, we can hopefully, reduce those greenhouse gases then. It's not just a sort of simple matter of just making parts lighter weight. Sometimes the materials involved have to be, robust enough to, endure car crashes and to be able to support the weight of things. And so that's why we need to find parts that are both lightweight and strong. And so that's why my work is trying to find parts that have both of those factors.
So the initial aim of the project was to search around all sorts of different animals that have structures that could potentially be applied to some form of automotive application.
I was using my background knowledge in zoology and thinking about all the different animals and insects, what parts of them might be useful. And then I thought, the pelican, that's got a very long beak. How does that work? When it's fully loaded and it can carry up to 14 litres of water and prey, it's got to still be lightweight. It's got to be able to keep its head up. I know there's some, probably some good musculature involved in that, but it's still going to be pretty strong. So we managed to get a pelican skull and beak, and we put it in, did some X-ray CT on it, and discovered this interesting structure.
When I first saw this internal structure, it's incredible. It just looks like it's man-made, whereas a human bone has a regular, almost foam-like structure inside. In the pelican mandible, it's very distinct individual struts, and they're occurring at almost 45 degrees to vertical, all the way down.
Using Abacus, we created a model and meshed that, and we replicated them according to the original model and to see how they would perform.
And what we can do with simulation, we can play around with that structure and see how the performance from an engineering point of view changes. So for example, we can strip out all the internal structure and run a bending analysis. We can then put it all back in and see how different the behaviour is.
You could really see how the beak was managing to not break, not fail during under stress.
There's definitely scope for using this sort of design or this sort of structure within engineering applications. So what I really like about the Simulia software, it's really flexible. You can write custom scripts using the Python interface. You can write your own material behaviour using the user subroutines in Fortran. So from a research point of view, it's just a brilliant tool.
Things have evolved over millions of years, and so we look at nature to try and find architectures and structures that are both lightweight and strong.
Okay, I love simulation because it allows us to see what we couldn't previously see.